Hi everybody, welcome back to Algebra 2. Today we're going to talk about something called the quadratic formula, and we're going to talk about first where that comes from. So on page 101 in your workbook, you'll see an explore and reason with something that looks kind of scary, but I'm just going to talk you through what's happening in each step and show you how completing the square does turn into something called the quadratic formula. So that says you can complete the square to solve a general quadratic equation. So what's happening here is that somebody got tired of having problems like 5x squared plus 3x plus 2 equals 0. Somebody got tired of going through all the steps for completing the square every single time because they realized, you know what, I'm actually doing the same thing over and over. Can I take those steps that I'm doing and just plug them into a formula and get my answers without having to complete the square the entire time? So that's what they're doing here. So they generalized it instead of saying, well, we're always going to have different numbers for A, B, and C. So let's leave it as A, B, and C. Okay, but we're gonna take these constants and we're gonna do the steps for completing the square. So they have ax squared plus bx plus c equals 0. They are writing their equation in the form ax squared plus bx equals the c. Now they did make that c negative. Now in the previous examples, I told you to make sure that a equals 1, but if not, factor it out. That's one option. The other option that you have is to divide everything by that a coefficient. So that's what they've chosen to do here so that this a value is 1. So what they did is they divided all terms by a to make a equal to 1. So instead of factoring out the a like I showed you how to do, they just divided everything by that. All right, now this next step looks a little scary, but look, they're adding a term to both sides. Well, they did have this b term, that b over a, that's that b term. So they're taking it and they're dividing it by 2 and then squaring it and adding it to both sides. So this is that part where they add the b over 2 squared to both sides. Now it doesn't quite look like b over 2 squared, but it's because they're treating this b over a as we would say this was our new b, but they've kept it as b over a, and they're then dividing it by 2 or multiplying it by half. Okay, then what happened next is they took that, whatever they had, and they factored the left side. So that's how they got x plus b over 2a squared. Okay, now what's this coming from? It's coming from them actually squaring out b squared is b squared, 2 squared is 4, a squared is a, and then they just move this c to the other side. So they factor that left side. Then what they did here is they combined these two fractions to get a common denominator. And don't worry too much about how they did that denominator. You just need to be able to watch this and see what's happening. They got a common denominator. Then they solved by taking square roots. Or in other words, they took the square root of both sides. And then after they took the square root of both sides, they just subtracted b over 2a on both sides and got a common denominator again and ended up with this. What is this? Something you're going to need to memorize because it is going to pop up for the rest of your math career. This is called the quadratic formula. How on earth am I ever going to remember what this formula is? Well, guess what? There have been thousands, probably millions of songs written about the quadratic formula. So let me play one for you. Oh, look, I have one right here already. Here we go.
X x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yay! Oh, wait. I have this. Okay, so hopefully that's got that song kind of in your head. If you forgot, feel free to rewind and play that song all over again. But yes, you are going to need to memorize that. Even if you get to use your notes right now, eventually you're going to have to return in person someday, and you're going to need to be able to use the quadratic formula. So let's talk about solving using the quadratic formula. Again, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're going to solve this using the quadratic formula. The first thing that I need to do is I need to identify, even before that, first thing that you need to do, number one, is you need to set it up in standard form. Set equation equal to 0. So is my equation equal to 0? Check. Step number 2, I need to identify A, B, and C. You've already been doing this a little bit, but since you're identifying A, B, and C, so A is 2, B is 6, C is 3. Then you can substitute them into the formula. So we're going to apply the formula. And then after you apply the formula, which we'll do in just a minute, you need to simplify with the order of operations. All right, so let's try this out. I'm going to apply the formula. X equals negative b, so negative 6, plus or minus the square root of b squared, which is 6 squared, but I'm going to go ahead and square that in my head. 36 minus 4 times a, which is 2, times c, which is 3. The whole thing is over 2 times the a coefficient, which is 2. So I applied the formula. Check. Now I need to simplify using order of operations. Order of operations say that we do parentheses first, so that means I go inside the grouping symbol and I simplify what's going on here. I see 36 minus 4 times 2 times 3. I don't subtract first. I multiply these things together first. So I'll have negative 6 plus or minus the square root of 36 minus 4 times 2 times 3, I think it's 24, but I'm going to grab a calculator and double check. Yes, so 36 minus 24, all over 2 times 2, or all over 4. Now I'm still inside the grouping symbols. This is grouping symbols act like parentheses, so order of operations say I still go here. So x equals negative 6 plus or minus 36 minus 24 is 12, so the square root of 12, all over 4. Then I'm still in the grouping symbol because I can still simplify the square root of 12. The square root of 12 simplifies to 2 square root of 3, because the square root of 12 you can write as the square root of 4 times the square root of 3. The square root of 4 is 2, then I have square root of 3, all over 4. Okay, so I've simplified the radical. Now I can look at dividing. Now when I divide, I can't divide 6 by 4 evenly. I can't divide 2 by 4 evenly, but I can reduce these fractions by a common factor. So I can reduce 6, 2, and 4 all by a factor of 2. And since 3 is under a radical, it doesn't get reduced at all because we work with that differently. So divide all the outside numbers by the same factor. We get x equals negative 3 plus or minus 1 square root of 3 all over 2. Now, that 1, we don't have to write it like that. Negative 3 plus or minus the square root of 3 all over 2. Now, you may not realize it, but this is actually two different answers because we have the plus or minus symbol. So this is equal to negative 3 plus the square root of 3 over 2, or x equals negative 3 minus the square root of 3 over 2. So we do need to realize how many answers we have here. We also need to realize another way that I could write this answer is if I were to break up the fractions, because negative 3 plus square root of 3 over 2 is the same as negative 3 over 2 plus the square root of 3 over 2. It's really important that we can recognize all the proper ways that our answers could be written. Negative 3 minus the square root of 3 over 2. And you can break up fractions as long as you only have one term in your denominator. All right, so we did all of this work. How many answers did we get? We got 2 answers, or 2 solutions. They ended up being real numbers, so they were 2 real solutions. I know that they're real because there's no i's, there's no imaginary numbers. They're real, and then are they rational or irrational? Irrational, because if I were to grab a calculator and type this in, I would get a decimal that does not repeat or make a pattern or terminate. So these are 2 solutions that are real and irrational. Example 2 says to choose a solution method. We're going to solve the equation 6x squared plus x minus 15 using the quadratic formula and then one other method. So I've listed all the methods that we've done so far this chapter, and then we'll come back and fill in some more information about this stuff in just a minute. But first, let's solve using the quadratic formula. It is in the form ax squared plus bx plus c equals 0. My a is 6, b is 1, and c is negative 15. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to substitute in values for a, b, and c. X equals negative 1 plus or minus the square root b squared, so 1 squared is 1, minus 4 times a, which is 6, times c, which is negative 15, all over 2 times a, which is 6. Then I'm going to simplify inside the radical. So negative 1 plus or minus the square root of 1. Let's see, 4 times negative 6 times negative 15 is plus 360. All over 2 times 6 is 12. So I have x equals negative 1 plus or minus the square root of 361 all over 12. And the square root of 361 is 19. So x equals negative 1 plus or minus 19 over 12. And I'm going to get 2 answers from this. I'm going to do the first answer I'll get as saying x equals negative 1 plus 19 divided by 12. And the second answer I'll get from doing negative 1 minus 19 divided by 12. So negative 1 plus 19 is 18, and 18 divided by 12 is 3/2. And then the other one, negative 1 minus 19, is negative 20. Negative 20 divided by 12 is negative 5/3. So I get 3/2 and negative 5/3. Now, we're supposed to solve that same equation using one other method. So here's the methods that we've done so far. We've done factoring, square roots, completing the square, and quadratic formula. The thing about factoring, the nice thing about it is that it is quick, but it doesn't always work because it doesn't work when it won't factor, but not everything factors. Square roots are also quick. That's another quick method. Quick. It's quick. And again, use square roots whenever you have something like x squared equals 9 or x squared equals -9. You can just take the square root. The only problem is it only works for perfect squares or perfect squared trinomials. Completing the square is an option that we can use. Completing the square always works. It will work for all different types of solutions, and so will the quadratic formula. So why don't we just use completing the square or quadratic formula every single time? Well, completing the square, there's lots of steps. Quadratic formula is a big formula, so you may not want to use a huge formula or a lot of steps every single time you solve a problem. That's why factoring and square roots they might be an option. Now I'm going to try this one by factoring because that's option 1. So let's see if it will factor. Let's see. I'm going to break it apart into 2 sets of parentheses, set it equal to 0. Let's try 6x and 1x. And then to get 15, I can do 1 times 15, 3 times 5. So let's try a 3 here and a 5 there. The inner product will be 3x. Outer product is 30. That won't work. What if we try switching those? Putting the 3 first and then the 5. Wait, I think I just did that. Yeah, 5 first and then the 3. So then I would have 18 and 5 will not add to be 1. Okay, so maybe we'll try, instead of 6 and 1, let's try 3 and 2. So when we try 3 and 2, I'll have a 10x and a 9x. And let's see, if the 10x is positive and 9 is negative, that should work because that would multiply to be -15 and that would multiply to be positive 10. Okay? So then I can set each factor equal to 0. 3x plus 5 equals 0. 2x minus 3 equals 0. 3x, subtract 5, you get -5. X equals -5/3. Hey, look, there it is. And then 2x minus 3 equals 0. 2x equals 3. X equals 3 halves. 3 halves. Now, look at all the steps we had to use for quadratic formula. Look at all the steps we had to use for factoring. In this case, because it did factor, factoring looks like it could have been faster, but quadratic formula also works in this instance.